I posted this document on Schoology for you guys. We're not going to do the whole document today. We're just going to do question 2, 4, and 5, and then next week we will do the rest of the packet. That'll count as 3 days next week. So I hope you guys are studying for this exam, and this is how you study. It will be open book and open note. So first of all, for number 1, you do not need to know any definitions for this exam. It might be a good idea to just kind of read through them, but don't feel like you have to write down any kind of definitions. So question 2, you're conducting a study of students doing work-study jobs on campus, and here's the questions in the survey. How many hours are you scheduled to work each week? How applicable is this work experience to your future employment goals? So answer the following: 1, not at all; 2, somewhat; 3, very. That would go with B. Okay, A, how many hours? You would just say how many hours. So what is the variable for question A? And that would be hours that they work. And is it quantitative or qualitative? So that would be quantitative. I just think of the word quantity. It has to do with numbers or numerical. B, what's the variable for question B? And it's basically how well your work experience applies to your future goals. So this would be a qualitative answer for that. Okay. C, is the proportion of responses 3 vary to question B a statistic or parameter? So let's say you gave this survey to 100 people and the proportion of people that said yes vary. A statistic or a parameter? That'd be a statistic. Remember, statistics are from the sample. Parameter would be if you knew the entire population. D, suppose only 40% of the students that you selected for the sample actually responded. So only 40% of the students sent back their survey. So what's the non-response rate? That would be 60%. And do you think the non-response rate could introduce bias to the study? And I would say yes. The students that did not respond, their input is important and could sway your final results. And then question E, would it be appropriate to generalize the results of your study to all work-study students in the nation? And I would say no, because you only ask students on your campus. So it does not apply to the population of the whole country, but it would apply to the population of your campus. Okay, 3 we're going to skip. You're not going to need to make a circle or a pie graph on your exam. Question number 4, this deals with, so if you were outside and the trunk or the circumference of a tree in millimeters for a random sample of 64-year-old apple trees in England. So 108 millimeters, that'd be like the distance around this apple tree. And here's our data. So we're asked to make a stem and leaf display. I'm going to get this started, then I'll push pause and then finish it so you don't have to watch me do this whole thing. But you kind of want to look for your lowest and your highest number. So it looks like 91 is our lowest and is 122 our highest. So when you do a stem and leaf plot, these numbers here are the stems and these are the leaves. So I'm going to say this is going to be like the 90s. This will be in the 100, like 100 to 109. This would be like 110 to 119. And then that should cover everything. So you want to have these in order numerically. So 91 is our lowest number, and I'm going to kind of try to get all the 90s. It looks like we just have 3 more 99s. Remember, you do not put any commas in your stem and leaf plot, and I'm going to push pause and finish. All right, so here is kind of what I came up with and crossing off the numbers as I go. Just make sure you remember to make a key, and you can pick any number from this key because we want to make sure that we know this means 91 and not just like 9.1. And we're also label it millimeters. So please remember to put a key on that. So one of the things that Rhodes really wants you to make is a histogram by hand. We're using the same data, but it's going to be helpful, I think, to use this because they're all in order. And what's nice for us is, and they're going to do this on the exam too, is they tell you how many classes they want and they get this started for you. So if you guys look from 91 to 98 to 105, do you see how they're adding 7 each time? Now, we don't want to double count. So we don't want to put 98 right here, or how would you know where to tally mark 98? So you want to do one lower here. So we're going to say 97, 104, 111, 118, and then for the last number, I know the highest number of trees is 122, but you want to keep on with this pattern of adding 7, so we're going to say 125. Class boundaries, that's where you go a half a unit off on each side. So instead of 91 to 97, we would say 90.5 to 97.5. Same thing here, 97.5 to 104.5. So I went ahead and finished that, check over those numbers, and this ends up being the numbers on your x-axis. If you want to kind of make a note of that. You could use Open Notes, Open Book. So I suggest you're filling in these notes. This is going to help you a ton when you take your real exam. I crossed off the midpoints and the cumulative frequency columns. Those will not be included on the exam. Okay, frequency is just how many times these numbers occur, and it should be really easy to see. So 91 to 97, I only have that happen one time. 98 to 104, 1, 2, 3, 4, 5, 6, 7, 7. Okay, 105 to 111, 1, 2, 3, 4, 5, 6, 7, 8, 9. 112 to 118, 1, 2, 3, 4. And then 119 to 125 is 2. Relative frequency is when you take the frequency and you divide it by the total number. So we have 24. Oh, notice up here, there used to be 60 numbers, and that one took so long, so I just deleted some numbers there. So there's 24 numbers, that's our sample size, and then you can turn that into a decimal. I'll do that in a second. All right, so I went ahead and finished those relative frequencies. You can check those values with your calculator as well, and I've gone ahead and labeled my x-axis. So you use these boundary numbers, and you don't need to put the dashes in, like in between them. It's just each one of those dashes represents 90.5, 97.5, and see how that's repeated again? You don't have to write 97.5 again. So this asks us to do a frequency histogram. That means you use this as your y-axis. If they ask you to do a relative frequency histogram, you would use these decimals as your y-axis. Notice our highest number is 9, so I'm going to go 2, 4, 6, 8, 10. And you can just write F for frequency. Don't forget to label your X and Y axis. Remember, your bars are going to be touching. This is only one high. From 97 to 104.5, it's 7 high. And the next one is 9. And then 4. And then 2. So there is your histogram. All right, Mail Notes, the first thing I did is I put these numbers in numerical order because that's going to help us find the median. The mean is just the average of the 8 numbers, and I know you guys know how to find the mean. You add them all up and you divide by 8. And that would be, so for the mean and the mean symbol, it'd be 36.2. But then we would need to divide that by 8, so about 4.5. The median is just a capital M, and it's the middle number. Notice that there's an even number, so it's going to be right in between 3.9 and 4.2. So all I have to do is add 3.9 and 4.2 and divide by 2. So I'm going to find the average. So I'm going to call that 4.1. And then the mode is the most occurring, and there's not really a symbol for mode, you just write the mode, and that would be 1.9. Okay, sample, standard deviation, and range. Range should be easy. You guys remember range is just the highest minus the lowest. So that's just 8.6 minus 1.9, so that is 6.7. All right, the sample standard deviation is this formula, okay, and it really isn't that hard. X bar, anywhere you see X bar, we're going to plug in our 4.5. Our N is our sample size, and there's 8. So your N is 8, and that means N minus 1 is 7. Okay, you want to do this part first. So you want to take your first X value minus the mean and square it. And I'm going to show you how you do this in your calculator. 1.9 is the first X minus the mean, 4.5 in parentheses, and squared. And I get 6.76. So I'm going to write 6.76 plus I'm going to get another 6.76. I'm going to check mark as I go. Then I'm just going to replace with 2.8. And that's 2.89, and I'm going to continue this. I've done that. Notice I have 8 numbers here, and that again is the x number minus the mean squared. And then I just kind of wrote the answers down. So if we look back in the formula, we've already dealt with this. This symbol means you add them all up, and I've already done that in my calculator. And I got 42.4, and now let's just fill in. That's the answer for the entire numerator. We want to divide by n minus 1. So if n is 8, we want to divide by 7, and we want to square root that answer. So the square root of 42.4 divided by 7, and that's 2.46. So our standard deviation, sample standard deviation, is 2.46.
All right, it's Sunday evening, and it's been an awesome day. It's cloudy now, but we enjoyed being outside. We were out in the pond, did some yard work, and did a lot of jumping on the trampoline. Should I put my camera around? There's my dog. So, for bonus, I want to hear something fun that you did on Sunday.